Okay. Aloha, everybody. Thank you for joining us tonight. I'd like to welcome you to our presentation on Talk Story with the National Weather Service. My name is Gavin Imamura with Aina Haina Prepared. We're a community group located here in Aina Haina, and we do a lot of awareness and disaster preparation and assistance with the community here as part of our mission. And tonight we'd like to present to you a session on hurricane preparedness. So with that, I'm going to introduce John Ravender. He's with the National Weather Service. He's been here since, was it 2006 now?
Yep.
Roughly. And I'm going to introduce him and take it away, John.
Great, thanks, Gavin. Good evening, everyone. Thank you for joining us. This will be a first for us, going through a virtual presentation like this, and we hope you get something out of it. I'd like to also thank one of my colleagues, Vanessa Almanza, who's here helping out with the monitoring the chat and helping out with questions. So as we're going through this, you're all muted right now. If you have questions that pop up as you go through this little talk, we'll get to them at the end, and feel free to type them out if you want to. Otherwise, we'll have a chance for some verbal discussions afterwards as well. So we'll go just a quick couple short little slides, talk a little bit about last year, what happened, and our outlook for this year, and get to the talk story portion, try to answer any questions that you might have about hurricane season or whatever happens to come up. So with that, I'll make a first comment that we talk about hurricane season, but throughout this presentation, I'll be using the term tropical cyclone. That's a generic, there we go. That's a generic term that we use for all different intensities of systems, hurricanes, tropical storms, and tropical depressions. The satellite image on the screen here is from 2014, where a good capture of everything. On the low end, we have tropical depressions with winds less than 10 miles an hour. And example of that would be Genevieve over on the left-hand side of the image. A little spotlight here. That. Get rid of this. Try to, at least. Okay, well, let me just hide. Well, so let's try that again. Over on the image over here, Genevieve is a tropical depression. Wind speed is less than 39 miles an hour. You might wonder why Genevieve has a name, even though it's a depression, unlike 1E that developed before hurricane season started off in the East Pacific. That was also a depression, but it doesn't get a name until it reaches tropical storm strength. In this case, in 2014, Genevieve had reached tropical storm, but then weakened again. At this point in time, it was a depression, but pretty soon after that, it went through some rapid intensification, became a hurricane and major hurricane just before crossing over the international date line, and then moved into the Western Pacific and became a super typhoon. Next up, we have a tropical storm with wind speeds between 39 and 73 miles an hour. In this case, Julio is a good example of that. At this point in time, Julio was a storm. Eventually, it strengthened to a hurricane and actually came towards Hawaii just after Isel did. And then the big one here in the middle with a very large eye is Hurricane Isel, which you may remember from, it weakened before it reached Hawaii, but still was a very strong tropical storm by the time it made landfall on the Big Island. And Isel was the first tropical cyclone to make landfall in the state since 1992, since Hurricane Iniki. At this point, it was a major hurricane with a very big eye. So this is a unique image we like to refer back to that shows all the different intensities of tropical cyclones. So even within a hurricane, we categorize based on wind speed using the Saffir-Simpson hurricane wind scale. So you might hear the terms Category 1, Category 2, 3, 4, 5. These are all defined by the strength of the winds. It doesn't really consider anything else. It doesn't consider the size or how much rainfall or how much waves or storm surge are with it. It's just by the wind speed. And here on the slide are a few examples. Isel, this is one a little bit later, just before it made landfall when it was a tropical storm. Category 1, Eva in 1982. Flossie keeps coming back to us. This one from 2007 was when it was a hurricane that passed south of the states. One of the, seems like every 6 years it keeps coming back to haunt us. And then when you get to categories 3, 4, and 5, those are sometimes grouped together as major hurricanes. But even though there's very significant impacts possible with those major hurricanes, any category 1, category 2, even tropical storm can cause a lot of damage, especially with power lines and anything like that. So where do tropical cyclones form? This is a map that shows a big spaghetti plot, everything that we've seen over since 1970. Greens are tropical depressions, yellows are tropical storms, red is hurricane, and purple is major hurricane. So on here you see a lot of activity in the Eastern Pacific. Eastern Pacific is a lot busier than the Central Pacific. A lot that develops here. They occasionally move off to the north, move into cooler water and weaken, but a lot of the tracks move east to west. And even as we get into the Central Pacific, which for our definitions is between 140 west longitude and the international date line, or 180. Even through the Central Pacific, the bulk of our activity is located south of Hawaii, generally moving east to west. Hurricane Hector, 2018 was a good example of taking that track. Even Eric last year was one of those east to west tracks. Here. And then just from throughout the year, a rough guideline, we got hurricane season being from June 1st to November 30th. Here in the Central Pacific, the bulk of our activity occurs from July, last half of July into the first half of September, with the peak being in August. There's also the peak being here in August. And there's a little tail off, a little longer into the end of the year. During El Nino years, we tend to be more active. El Niños, there's usually warm water in the area, and we tend to have longer seasons. So there's some here. For example, November has 3 tropical cyclones since 1970. But if you remember before, Hurricane Eva in 1982 was the one that brought some significant damage and impacts to Hawaii, was a late November hurricane. So I'm going to pause here for a second and ask you a quick question, a poll question. You'll see it pop up on your screen. Before we start talking about next year, we'll give you a chance to answer this question. How many, before we were talking about last year, we'll test your knowledge before we get into that. How many tropical cyclones were there in the Central Pacific? So click on the answer that you think, and then click submit. So it looks like we've about half the folks have voted so far. We'll leave this open for a few more, for a little bit longer. Okay, looks like we're slowing down. I will close that poll and share the results with you. So the 4 tropical cyclones took an early lead, but eventually 5 took over. So this is actually a pretty wide distribution. So I'm glad you're here with us to talk about this. And of course, this was somewhat of a trick question. I designed this to be confusing because I'm mean like that. So we'll jump back to the screen here and look at what happened last year. And because I'm a meteorologist, I can't give you a straight answer. So we'll start off with this slide here, talking about 5 or 6 tropical cyclones. I always like to include Barbara on this list because it was a threat. It was looking like it might be a threat to Hawaii before it crossed 140. It brought us impacts, but it weakened to a remnant low before it eventually crossed 140, so it never came into the Central Pacific. So when we ended hurricane season, we ended with 5 tropical cyclones. Here's the 5 on the list here. But you notice Kiko was came in as a tropical storm, was a very low-end system, weakened very quickly after it came in. Now, after hurricane season is over, we go back and realize all the okay, Danny, I just muted you. After hurricane season is over, we'll go back and reanalyze all the positions every 6 hours, look at any new data that came in, what happened before, what happened after that time period, more information than we had available during hurricane season, during the live forecast at the time, and create what is called the best track. This is the best possible, from what the information we have, the best possible location, intensity, size of the wind field, everything like that. And that becomes part of the permanent climate record. And during the reanalysis for Kiko, we came to the realization that it had weakened before it crossed 140. It actually dissipated about 139. So with an update in January, we ended up striking Kiko from the Central Pacific list. So the final answer, after all that talking, gets to be 4 tropical cyclones. That is the what is going down in the record books. Here we are in 2019 4, and you can see where that compares to previous years. Average for us in the Central Pacific is about 4 to 5, we say. The actual number that works out is 4.7, just the way it averages out. So we always say roughly 4 to 5. So that 4 is right about normal. I guess actually, while we're on the slide, let me point out a couple things. One of the big influences on how busy the Central Pacific is from a seasonal standpoint is the El Nino Southern Oscillation. During warm years, during El Nino years, Central Pacific tends to see higher than normal tropical cyclone activity, warmer waters, less wind shear. And during La Nina years, the cold phase, we tend to see less activity. And the Pacific and the Atlantic are somewhat opposite. So during El Nino years, we have less shear and warm water in the Pacific, and there's more activity in the Pacific. And in the Atlantic, there's generally more wind shear, which is changing wind with height. And more wind shear is more detrimental to hurricanes, so they tend to have less activity. And when the Pacific is quiet during a La Nina year, then the Atlantic tends to be busier. So when we have a quiet season, Atlantic tends to have a positive season. So some big El Nino years really jump out here. 2015 was a very strong one. That was our record-setting year. 92, 97 were also big El Nino years. 92, of course, with Iniki hitting Kauai. And then during La Nina years, we tend to be very, very low. There's also a larger pattern, multi-year pattern that on top of this. Here in the 70s, generally low activities. As get into the 80s, into the early 90s, generally more. Get into the 2000s, into the late 2000s, less activity. And here over the past decade or so, more. There's something called the Pacific Decadal Oscillation that we're into the positive phase of, that is overlaid on top of that El Nino La Nina influence. So we had 4 last year. We'll take a look at a few of those. Not one of the 4, but as I mentioned, Barbara, weekend before it crossed 140 into the Central Pacific, it still brought some impacts to the state. It was a major hurricane for a period of time and generated a lot of big waves and a lot of heavy seas with it. That created some high surf along East Facing shores in the first part of July, the second week of July or so. And also after a weekend, there's still a lot of tropical moisture left behind that, as that moved through, brought some heavy rain to Maui and Hawaii counties. Also mentioned Hurricane Eric. Eric was the one hurricane that we had last year. It was also a major hurricane. that passed south of the state. Major hurricane, also a lot of waves with that brought some high surf to east and south facing shores at the beginning of August. And moisture from it also brought a couple periods of heavy rain, first across the Big Island, and then a couple days later across Kauai as well. Mentioned Flossie. Flossie is one of those systems that keeps coming back every 6 years. Tropical for the Eastern Pacific, tropical cyclones are named from a rotating list. It goes down alphabetically, and there's 6 of these lists, and they repeat every 6 years. So Flossie, it passed by south of the state as a hurricane in 2007, like we used for that example of the Category 2 hurricane. 2013, it came back again and actually took a track very similar to this one. It came in as a tropical storm, dissipated east of the state, brought some impacts, a little bit of wind, some rain, caused some power outages, but wasn't as significant as we were fearing. And then 6 years later, this past year, Tropical Storm Flossie came in. No, it was a hurricane at one point in the Eastern Pacific, but this yellow track here, as it moved through the Central Pacific, it was when it was a tropical storm, and then green is where it weakened to a depression. Eventually dissipated before reaching us and then turned north a bit. But still, as it was a storm, it generated some surf for east-facing shores, and then remnant moisture brought some heavy rain to Oahu, to Maui County, to the Big Island. Now Kiko, like I mentioned, we pulled Kiko from the Central Pacific list. It had dissipated just about 139 west. These lines here, make sure the image updates. See my pointer? So you can. The dotted line, here you go. The dotted lines are the where it was a remnant low after it had stopped being what we consider a tropical cyclone. So it was a storm up to this point and then lost all thunderstorms with it. But the weird thing about Kiko is that it formed just about 110 degrees longitude, not that far away. And it was out there for almost 2 weeks. And it took this very meandering track. It went through some rapid intensification, became a major hurricane, but then also weakened, became a storm, and then started oscillating back and forth. It turned southwest and northwest and southwest. It was moving really slow. So over the course of the 12 days it was out there, it really only averaged about 6.5 miles an hour. And if it was moving more in a linear fashion, more east to west, it actually would have come into the Central Pacific Basin and might have had some more impact on us. So we mentioned overall we had we ended up with 4 total last year. This is the outlook from the season outlook that we did for last hurricane season. We were expecting a busy year. The hurricane outlook had a 70% chance of an above normal year. Numbers wise, we were talking 5 to 8 tropical cyclones. We ended up with 5, or I'm sorry, we ended up with 4. And the big influence on this outlook is, as you mentioned before, El Niño. When we put this outlook out, we were in weak El Niño conditions. Right. Slide updates. We were weak El Niño conditions. El Niño is defined by 0.5 degrees Celsius above normal, or in a certain area of the Earth, right along the equator, between about 140 west and 170 west, right along the equator itself. So 0.5 degree warmer than normal gives you El Niño conditions, and 0.5 degree cooler than normal gives you La Niña conditions. So this is roughly, if you can see the highlighter, this is roughly where we were going into the outlook last year. We were weak El Niño. We were expecting that to continue. And then what happened? The Pacific decided to cool off, much to our benefit, I suppose. We dropped off to near normal for a point during the summer. Recently, we've warmed up again and are right around 0.5 degree for a point. But before I talk about what's out there now, this is one way of looking at the temperatures in the ocean. It's just in graph form. That area defined what the average is for that area. And this graph is a 3-month running average. So it lags a bit from what we're seeing now. So as you see on this graph, we're almost at that 0.5 degree, We haven't had an El Nino definition. We're still ENSO neutral. But we actually, when we look at more details on the next slide, you'll see some cooling that's going on there right now. So hopefully the animation is coming through. It's a little slow on my end. For that, I apologize. Hopefully it catches up. These two images, the image on the left is ocean temperature, what the temperature of the ocean water is measured by satellite for a 1 week average. It's looking, satellites go by, they measure it and average it together, composite it together. So each of these images is 1 week of average temperatures. The one on the left is what the ocean temperature is in degrees Celsius for the scale. And the image on the right is what we call the anomaly. It's how much warmer or cooler than average it is. And it's this area right along the equator that is where we define El Nino conditions. And okay, there we are, the pointer. And this last image that it's frozen on shows some of the cooler water that's showing up there over the past couple weeks. So that points us more towards neutral conditions, or even some heading a little bit below normal along the equator. That area along the equator is what defines El Nino. But the other thing that you can notice is a little bit warmer than normal water near Hawaii itself. That hurricanes get their energy from warm water. We're not as warm as we have been over the past year or two, but there's still some warm water out there. And if anything does form at a higher than normal latitude, that warm water could give it some strength to keep going, to maintain its intensity. So from an outlook standpoint, all of our climate models that we have, they put them together into this probability graph that you see here. These are 3-month averages showing chance. The gray bars are ENSO neutral, which is where we are now. Blue is La Nina, or cold phase, and red is El Nino, the warm phase. So as we head into the summer, still pretty good likelihood of maintaining ENSO neutral conditions. And later, as we go into the year, increasing chances for La Nina developing. So this is one of the big inputs to the seasonal forecast. And before I get to that big, well, reveal, I'll give you another poll to test your knowledge of what our hurricane season outlook is. So choose one of the options and click submit. Looks like about half the people have voted. We're up to about 2/3. All right, I will wrap this up, close the poll, and show you the results. So there you go. The majority of you got it right. Oh, wait. So I should say the majority of you say 2 to 6, and hide that. Get back to the reveal, and the majority of you were right. You've been paying attention, because you got a good audience for knowing what's going on with hurricane season here. So for the season outlook, looking at 75% chance near to below normal season based on those ENSO neutral conditions, possibly switching to La Nina. 2 to 6 tropical cyclones is the number. It's a bit of a larger range than normal. Normally it's like 3 to 6, 4 to 7, 5 to 8. We went with a little larger range just with that uncertainty. We're hovering right near that El Nino definition initially when we put this outlook out a couple weeks ago. What we've been seeing since then is a bit of cooling, which makes me more comfortable with the near to below normal portion of this. But every time we talk about the season outlook, We always try to emphasize to everyone that this is for the Central Pacific Basin as a whole, between 140 West and the dateline. This doesn't give any indicator of potential threats to Hawaii itself. You could have a very busy year like 2015 and not have a lot of impacts across the state, or you could have a very quiet year that, even if you only have one hurricane, if it hits Hawaii, it'll be devastating, whether it's busy or quiet overall. So that's why we always tell people, regardless of whether it's a active season or a quiet season that we're expecting, you need to prepare like this is like the big one's going to occur. And with that, I think that's a good segue to toss it back to Gavin and talk a little bit about what you can do to prepare.
Thanks, John. Now, as John had just previously mentioned, we need to be prepared, and there's no rocket science to this. A lot of it is just, what you need on a day-to-day basis. And with that in mind, I'm going to talk about a Go Kit and the 14-day supply. And things have changed a bit because of COVID-19. Before we'd say, okay, get some clothes, get your medication, have some water handy and whatnot. But now you're going to need stuff like an N95 mask or those cloth masks that you can reuse on your face and whatnot, or face coverings, disinfectant, Lysol, hand wipes, hand sanitizer, etc. You're going to need those. Now, the reality of it is it's harder to find those things because of COVID. And what's a good example is, people weren't prepared. And what had happened was it led to hoarding, and now the demand has outweighed the supply. So things are harder to find. So basically what you need to do is be prepared. Have stuff on hand that you think you need for a 3-day supply, clothes, bottled water if necessary, snacks, medication, secure your personal ID, stuff like that. 14-day supply, that's when it gets a little more trickier because, again, demand has outweighed supply. It's harder and harder to find stuff. So instead of going out and buying cases of water, which is basically tap water, you can make your own water. Go out and buy containers. You can get empty 5-gallon water bottles and empty 3-gallon water bottles from Walmart for a nominal fee. And you can basically make your own tap water and sterilize it with a drop of bleach per gallon. And that'll get you going for what you need for water. And have a good supply of canned goods, 14-day supply, what you need. Medication, make sure you have enough medication on hand, because when power goes out and all hell breaks loose, it's going to be difficult to get those items. So basically think about what you need. It's not rocket science. There's no, okay, you must have these things in your kit. Have a battery operated radio. That'll help, so you can listen to guys like John who can tell you what you need to do or what's coming down the pipe. And you can also hear where you can get supplies like ice, blankets, food if necessary. So be part of the solution, not the problem. Be prepared. That's what we emphasize over and over again. And make sure you have what you need, your supplies, and be ready. That's all I have.
Great, thank you. So, glancing through some of the questions people submitted, I noticed one that I was somewhat expecting to get, given Cristobal going off in the Gulf. Here, let me share my screen again, show you a couple different things. So, given Cristobal going Bay of Campeche, meandering inland and potentially emerging back into the Gulf, and potentially heading for the Gulf Coast, a question came up: has a system ever crossed from the Pacific to the Atlantic before? And actually, the last time something or Pacific to Atlantic is more rare than Atlantic to Pacific, which is pretty rare in itself. But the last time we went from Pacific to Atlantic was in 2010. So we had this depression that formed, Depression 11E, here in September. It was very short to develop near the coast, moved inland, but weakened. The terrain pulled it apart. It weakened, and just had no low-level circulation, but had a mid-level circulation. And then that emerged back on the other side again, and eventually became Tropical Storm Hermine that tracked northward, went across Texas, and eventually into Oklahoma after re-intensifying. So that was one of the cases like we are seeing right now occurring. Going the other direction, 2016, you had Hurricane Otto formed very late in the year. Formed on the Atlantic side, actually meandered around a bit, then started moving westward, intensified to a major hurricane before making landfall, and was a hurricane as it tracked across land. Looking at the Tropical Cyclone report, it references following the eye on radar from Nicaragua as it moved through, eventually emerged on the Pacific side as a tropical storm, and then gradually weakened as it moved offshore into drier and more stable conditions. So 2016 was kind of a weird year for the Eastern Pacific Basin. Normally for the Eastern Pacific, they have an alphabetical list. It goes down just like normal, but you have Orlean, that was the O storm from the Pacific list, and then you get down through Tina, and then you have Otto jumping in there at the end. But even before that, you go from Payne to Roslyn to Ulika. This was one that was named in the Central Pacific. It strengthened into a tropical storm and eventually hurricane on or west of 140 in the Central Pacific area of responsibility, and then went back east into the Eastern Pacific Basin before eventually coming back west and weakening. So it zigzagged as well. So in 2016, you had the Eastern Pacific getting invaded by named systems from both sides, actually. Okay, I guess extending the story a little bit further, because once I started digging into this, I started to geek out a bit to look up more of these. And back in the 90s, there's actually the question that prompted this, me digging into this, was about carrying the name, like why we would carry a name one time but not another. Even if it moves to the Atlantic to the Pacific, like Otto, it will maintain its name. If it weakens to a remnant low and loses all convection, then it'll redevelop and get a new name. But that's the way it is now. Back in the 90s, there is an agreement with the World Meteorological Organization, with the region in the area, that anything moving from the Atlantic to the Pacific would get a new name. So the last time that occurred was a dual name system. You had Hurricane Caesar in the Atlantic Basin, moved across Central America, and became Hurricane Douglas. It was renamed in the Pacific. What I found, this is the last time this occurred where they actually maintained Tropical Cyclone and they renamed it. But what I found interesting about this was that Caesar caused a lot of damage, a lot of destruction, and was retired from the Atlantic list. This occurred in 1997. It was retired and replaced. I'm sorry, this occurred in 1996. It was retired and replaced in 1997. And what was it replaced with? Cristobal, the one we have out there right now. So bringing that story full circle. Okay, so Vanessa, any other questions that we have out there?
Yes, we're getting a lot of questions. This one's for Gavin. Does Aina Haina Prepared have a website where they can find a list of suggested items for a go bag?
We do have a website. I don't believe we have any suggestions on there for a go bag. It's basically inahainaprepared.org. We just got the website up and running, so that's one of the things that we are going to put on the website. But to answer your question even more, a lot of it is you evaluate yourself. You know, what are your basic needs? You know, do you fit into a category where you need to have specialized items, like special medication or special equipment, you know, to move around, like a wheelchair or a walker or something like that. So really take a good hard look and see, you know, what you need in case of an emergency to get going, because help is not going to be around. You know, there's X amount of number of people in the community with X amount of number of first responders, and the number of people in the community greatly outnumber the first responders. So you're basically going to have to take care of yourself before the help can get to you in that case. So again, take a good hard look, evaluate yourself, and see what you need, and go from there.
Great.
Hey, Danny, would you like
and
to?
Another question, why does high pressure in the north have a tendency to weaken storms?
So it's actually what we call wind shear. It's changing wind with height. So a lot of times we have trade winds most of the time, high pressure north of the area, winds out of the northeast, and high in the atmosphere, winds are out of the southwest. So blowing at two different directions. And when you have a hurricane, it's a very upright circulation. It's a very three-dimensional organized area of thunderstorms. And that when you have winds blowing from different directions, that ends up tilting and disrupting the circulation that is going on. And that's what caused it to weaken. So if we had a high north of the area and above that, another high pressure winds out of the east through a depth of the atmosphere, you wouldn't have it ended up weakening. You just have it moving westward by those winds. But that's one of the things that helps us where we are, that on average we have a lot of wind shear over the state, and that does keep us somewhat sheltered at times, but any given day you could have a different wind pattern. If you don't have the high at the surface, if you have a big trough to the west of us, deep area of south winds coming up like you had ahead of Hurricane Iniki, you could maintain the strength of a hurricane as it moves northwards towards us.
All right, thanks, John. I guess another question would be, in 2019, it looked like most of the storms tracked north. Why?
Say that again?
In 2019, it looked like most of the storms tracked north. Why was this?
That was somewhat just happenstance, I think, but that brings up a pretty good question, or a interesting thing to discuss. Let me just bring up that map again so you can see it. Here we are. Let's go for the year-ending one. So, right, compared to that one graphic I saw you, they are tracked much closer to us, higher latitudes. So if I jump back to this, the climate one, here we go. A lot of the activity normally passes south of us. That's an area where the low-level winds are lined up with the high-level winds, which is generally low. Water temperature is very warm. But one thing that atmospheric scientists have been researching and published in the journal Nature, is a look back at the last several decades of time, and they've seen a poleward shift in hurricane tracks. I mean, in the northern hemisphere, they're shifting northward. In the southern hemisphere, they're shifting north or southward as the ocean water warms. That's the big contributor they're finding. It's not just ocean water. It has to do with large-scale patterns as well. We don't really know all the contributions, but one thing that they have seen is there has been a shift northward for us, which for us in Hawaii, that's bad news. That means that these hurricane tracks that are normally passing south of the state are coming closer. And that could be perhaps a bit of what we saw with the east to west tracks last year.
All right.
That was a pretty insightful.
Yeah. So another question, based on location and other factors, what is the likelihood of Oahu getting hit versus other islands? And has that changed over time? It seems historically Kauai and Hawaii have been affected the most.
I think that the difference across the state is pretty negligible. I don't necessarily feel safer on Oahu than if I were living on Kauai. Yes, in recent memory, Big Island has been hit recently. Now Maui, before that, Kauai repeatedly. Oahu is there as well. From a statewide standpoint, the chances could go anywhere. There's nothing in particular that protects Oahu. We saw with Isel and with Darby moving in from the southeast, they made landfall on the Big Island, and the mountains completely disrupted the low-level circulations. Darby was a good example of that. Darby in 2016, there was a storm, it moved in, the low-level center really just jumped from one side of the Big Island to the other, but it never recovered, it was weak. But even though it was a weak system, it still brought 10, 12 inches of rain to us here on Oahu. That brought down a lot of debris from that freshwater flooding that jammed up underpasses and caused a lot of other problems and a lot of debris problems as well. So from that direction, I guess we would be protected, but anything coming up from the south or from the east, it's still open game for any of the islands across the state, really.
All right. And we got another question. Are the warmer SSTs moving farther north each year now?
I guess the short answer could be yes. You want to, you're looking for ocean temperatures around 80, 83 degrees for hurricanes to really maintain their strength. Warmer than that provides more energy to them as well. As the ocean is warmer and that warmer water extends farther north, you could have hurricanes maintain their strength at farther north latitudes. That's one thing that we saw, especially a few years ago. 2015 was a very, very warm year, but even 2014 was another noticeable one where you had really warm water up to 30 degrees north. We paid a lot of attention to hurricane or tropical storm Isel, which hit the Big Island. But later that year in October, Hurricane Aina passed south of the state. It really slowed down and stalled south of Oahu and Kauai, brought us some heavy rain for a period of time, and 30 or 40 miles from bringing us massive excessive rainfall that was occurring offshore based on what our radar was seeing. But that moved west and then returned northward. And for a late season tropical cyclone moving northward like that, it actually redeveloped into a hurricane at a very north latitude. So that does give, so the warmer waters, having warmer waters farther north, does give more of a threat for hurricanes to maintain their strength that far north.
All right, and we have Tatiana who has her hand raised. So I think I'm just gonna unmute her and she can ask her
So
question.
actually, before we do that,
Okay.
I saw a chat from Danny in here. Danny, I've unmuted your microphone, so you should be able to talk again. Although I'm not picking you up. So there were a couple items that he wanted to ask me to mention. So one was talking about our weather spotter program, Skywarn Storm Spotters. That's we sit in our office and we are looking at computers. We're looking at satellite data and radar data, but we need information on the ground, what we call ground truth, what's actually happening out there. We can see radar that says you're getting a lot of rain in a certain area, but it doesn't tell us if it's running off like normal or if it's flooding or if there's damage occurring. And that's where our spotters come into play. We have, we'll go out normally, we normally go out and give presentations and talk about train spotters. Since we can't do that now, we're in the process of setting up some virtual ones. But in the meantime, we also have a video on our YouTube channel that goes through, is a recorded presentation. You can watch that. It talks about, it explains what the spotter program is, what information that we're interested in, how to report that, and provides that information. And I'll send that link into the chat momentarily. And coincident with that spotter program, we have an amateur radio network as well that will help get information to us during major events. If a hurricane comes in, there's going to be a lot of damage. We'll lose a lot of communication methods. And that's where the amateur radio volunteers in the field collecting reports and working in net control station in our office will help get that information to us, even if the phone system is down or internet is down and there's more information like that. So there's those are two of the big ways that we have for getting information into our forecast staff. All right, thanks, Vanessa. Can you go ahead to the next question?
Next question. Should I unmute Tatiana now? Okay. Tatiana, I'm going to unmute you so you can answer or ask your question.
Thank you. I actually didn't have a question. I just wanted to let everybody know on the call, they can go to www.hawaiianelectric.com/prepare. There's a whole quick tips there that people can just download and print. It's really, really easy that you can take it to the store. If you need a copy, you can call our office for one. We also have a very large handbook for emergency preparedness that people can download too or get their copies at City Mail. That's all. Thank you.
Thank you.
That is free. Thank you. That's the Hawaiian Electric is a very useful preparedness tool. And thank you for sharing that. Really appreciate it.
All right. So our next question is, do tropical storms, hurricanes suck up heat from the ocean and dissipate the heat, cooling the ocean?
In a nutshell, yes. The That's a really good question. Hurricanes do have a reason for existing. Ocean is I guess what we call part of a global energy budget. The sun hits the earth and heats up the ocean right along the equator. The sun hits directly and heats that up more along the equator. That's why the ocean temperature is warmer in the tropics than in the cold. And if there wasn't a mechanism to spread that heat out around the world, it would just keep heating up and heating up. So hurricanes can be thought of almost like a heat engine. They take energy from the ocean into the atmosphere, and then they move it away from the tropics and distribute it around the world. So it is part of a kind of a balance that the Earth has to make sure the sun's energy is distributed farther north, or farther towards the poles.
All right. So the next question is, when and how do we find out and decide if we should shelter in place or go to a shelter as a hurricane approaches?
Ooh, that's a good one. The best thing that we always mention, listen to your local emergency managers. They're the ones with the experience and will recommend when to evacuate and make those recommendations like that. For yourself, the first thing that you would want to do, if you're able, trying to improve your house. If there's any, now is the time of year where you can do retrofits if you can. Actually, that reminds me of another good reference from a Sea Grant publication that I'll put in the window momentarily, called The Homeowner's Handbook to Prepare for Natural Hazards. Talks about strengthening your house ahead of a hurricane. If you can stay in your house, that is the best option. You're there, you have your supplies, but you also have to remember that wind isn't the only hazard. Wind is one of the hazards. There's also a threat of flash flooding from rainfall, or there's a threat of seawater flooding if you live near the coast from storm surge. So that's something that's worth looking into ahead of time. Local emergency management office can help help you learn whether you're in a flood inundation area or if you would be safe where you're located. And then as a hurricane approaches, if you don't feel safe in your house, sheltering in place in your house, and you need to go to an evacuation shelter, that's kind of the last resort. There's limited space, there's limited amenities, and it's going to be even more of an issue now in the COVID-19 environment. The counties and the American Red Cross all have new shelter standards, more space, keep people separated, keep people isolated if necessary. So they're more spread out, which means there's less shelter space overall available. So that's the recommendation, is if you're able to stay in your home or with a friend, if you can't stay in your home, hopefully you have a friend or a relative that you can stay with that has a sturdier house. That would be the second best option. And if you can't do that, then there's the emergency evacuation shelters.
All right. So it looks like one more, I guess, another question. Is there a copy of this wonderful presentation?
There can be, yeah. Actually, we're recording this now, so we'll post this to the National Weather Service Honolulu YouTube channel. So it'll be available there if you want to refer back to it again. And I'll share the presentation slides with anybody that wants them. I had I guess my contact information up there before, but here I will send you my email address, john.bravner@noaa.gov. If you want a copy of the slides, just shoot me an email. I'll be happy to ship them off to you.
All right. And then we have a hand raised for Crystal. So Crystal, I'll unmute you and you can chat.
No,
Go
I
ahead.
just wanted to say,
Oh.
no, I just wanted to say thank you for all the people attending this webinar. John and Gavin, thank you so much. Did a great job.
We appreciate it. Yes.
All right.
And Crystal, if there's anything you want to add about preparedness information, sheltering information, emergency kits, please feel free to do so.
Yes, so I know that the information was provided by Gavin. Great job, Gavin, with the 14-day supply. If anyone wants to get more information, they can go to the City and County of Honolulu Department of Emergency website, www.honolulu.gov/DEM for Department of Emergency Management, so DEM. We have a lot of new information up there, really user-friendly. So hopefully that'll help get you folks prepared. And like was expressed in this webinar, with this COVID environment, it is important to be aware of the situation. We want everyone to be safe. So just like Gavin was saying, have your mask, have your gloves, have your sanitizing soaps and hand wash and so forth. Those are things that are going to be asked of you to bring if you ever go to a public shelter. But like John was saying, that's the last resort. So if you're able to, find a friend's home that was built, you know, with the hurricane straps and clips, and just start, if you're able to, you know, invest a little of that into your own home. It's the most important investment that most people make. Just like insurance, you want to do whatever you can to protect your investment. So take the time to work on it now while the skies are nice and clear and no storms are in our midst as of yet.
All right. Thank you, Crystal. We have another hand raised from Todd Wilson. I'll unmute you, Todd, and you can ask your question. Okay, Todd.
All right, can you hear me now?
Hey, Todd, we
Yep.
got you.
Outstanding. Okay, this question is either for John or Gavin, but whatever happened to the avian tropical color loop, which was a valuable tool for us out here outside of the National Weather Service office? We use that tool extensively with the within the ham radio community, and it suddenly disappeared here, I guess, a few months ago. Is that coming back, or is there going to be a replacement?
So actually, I just had a recent chat about this. Yes, so just let me share my screen really quick here. On our website, satellite page. So these are for people who want to know what we're talking about. These are the satellite images. It's a color enhancement for satellite images. And these links here are from the old geostationary satellite. There's a GOES 15 is the old generation one. The new one is GOES 17. And that's what these large links are for. We'll take you to a new set of images. The reason why we still have these old links on our website, the GOES 15 ones, is because right now it's just put in standby. There's a cooling problem on the new satellite that they discovered after launch. So at certain times, it heats up too much when it's looking at the sun. So actually at nighttime, if the sun is behind at the edge of the Earth, as it's looking at the Earth, it heats up the center too much. So we have bad data. So they've left GOES 15 in kind of a standby mode and expect to turn it back on in August and September to help during the peak of our hurricane season. So that's why these links are still available here. But from GOES 17 standpoint, looking at this for the tropical sector, there are image loops available using the new data. This is one, a new one that's combined. Try to call up an animation here. The drawback that I actually had a discussion with Kevin about this, is that the drawback is that you don't have the same overlays with sea surface temperature, tropical cyclone tracks if possible. That's something that Kevin is actually looking into, talking to NESDIS to try to come up with some workarounds. But in the meantime, there is satellite imagery from the new satellite available, and you can get to it just from how you saw me clicking on our website, the weather.gov/Hawaii. That help, Todd?
Oh yeah, yeah, that was such a valuable tool, especially as the hurricanes or the tropical storms got closer to the islands. You had a better idea the intensity and the size and also the speed. That was very important too, because conventional Doppler radars can't they can't accumulate it enough to where it can give you an idea of direction and speed, where the AVN tropical color loop could. So that's why it was such a viable tool. Back to you.
Thanks, Todd.
All right. I don't see any more hands raised. And I think we answered most of the questions. There's so many that came in. And some aren't questions. So I'll just scan through these.
Okay, so I guess we should call it an evening. You know, we had a little over time, but we pretty much stayed the course. So I'd like to take this opportunity to thank John for a wonderful presentation and taking some time out of his evening for us, and his assistant. I'm sorry, was that Teresa? Is that correct?
Yes.
Oh,
Vanessa.
sorry, Vanessa. Not even close. But anyway, thanks you guys, and thank you everybody for attending. We will have future presentations as part of our mission that will be announced in the near future. So thanks again for joining us, and thanks to John and Vanessa for their time and this wonderful presentation.
Thank you.
Thank you, Gavin. We appreciate you hosting this, and thank you everybody that's come out and taken time out of the evening to listen to us speak.
Alrighty, so let's sign off, and everybody have a good evening.
All right. Have a good night. Thank you.
Good night.